Alrighty. Hello everyone. It is 12:08 p.m. Sunday, June 22nd. I want to see if I can make this video a bit quick. Today I have a birthday to attend to, so gonna make sure I can get this video up and out. That way I can do birthday celebrations. Today it is hot, and it rained for like half a second. Like seriously, like I was driving. And like I drove through probably like maybe a 30-foot radius of a rain area. I'm not even joking. Like it was like that small. I was in it for probably about like 10 seconds, but it was pouring. So it was dry, completely dry. Drove into this giant pouring, or sorry, not giant. It was small. The pouring was the rain particles were giant. Like I mean, sounded like thunder hitting my car. And then, like, after being in that for 10 seconds, dry. Like, I did. Where I live, it is, dude, the weather is so bipolar. I don't even get it. But, today we're going to be continuing on with, what is this? Backtracking. Yep. Permutations. So, we did some permutations, mathematics, and whatnot. And discrete mathematics, and I think we also did this in statistics. Yeah. I don't remember the exact math behind all the permutations, but from my understanding, my recollection, it's basically like every single possibility. So, well, that'd be like a power set. Oh, okay, no, here you go. Yeah, this is permutations. Right. Because, okay. That makes sense. Well, this is interesting. So this isn't like a take. I have an idea. Let's look at this. This canvas. Like that. It just keeps going this way. Okay, we're gonna bounce back the other way. Oh, is it? Oh, it's raining now. Okay, that small little rain cloud just hit me. So now it's raining. I'm gonna give it like 10 minutes. It's gonna be dry again, guaranteed. Okay, so my thought process here is like, let's say we have 1, 2, 3. My thought process is, so take an empty array. We have two choices. We can add the 1, or we don't add the 1. Okay. And then from here, we can add the 2, or we don't add the 2. Wow, this is gonna be problematic though. I could see where this becomes a problem. Oh, the rain's already stopping. Man, not even 10 minutes. Crazy. We add the 3, or we don't add the 3. Okay, so this is finished. This is finished. This one can't go any further. This one, okay, so now this solution does not work. This does not work. it has too much duplications happening. I'm gonna have to use a hint on this one. Probably all of them actually. So, O of n squared or n factorial. That's the number of permutations. Permutation is the same as the array, but with the numbers arranged in different order. The given array itself is also considered a permutation. This means we should make a decision at each step to take an element from the array that has not been chosen previously. By doing this recursively, we can generate all permutations. Okay, so that's what I was thinking. But the problem is, like, I can get, like, we can use backtracking to explore all possibility permutation paths. We initialize a temporary list to append the chosen elements in a Boolean array of size n. To track which elements have been picked. Okay. Oh, I see. Dude, this one's actually kind of confusing me. This one's cooking my brain up. Well, I'll be right back real quick. Okay. Sorry. Skin was feeling a little dry, so I put some lotion on. We observe that every permutation has the same size as the input array. Therefore, we can append a copy of the list shows elements. But hold on. I'm seeing what you're saying, but, like, not truly, like, getting it, honestly. But this thing is going to keep going on forever, which causes an infinite loop. That is no good. That's a problem. So how do I get these without getting this infinite loop? Is the question. Let's do a simpler approach. 1, 2. Dude, I did this in my algorithms class. I can't believe I can't remember this stuff anymore. So I could take one, or I could not take one. Hold up. My earbuds are all twisted around. Okay, better. Actually, I don't even need my earbuds. I'm not listening to anything. This is silly. Yeah, I don't know how to do this one. Like, true to self. I'm fried. I give up.
Hey everyone, welcome back, and let's write.
I'm gonna accidentally brute force this, and like that's
problem.
not
Permutations. I've actually already solved this problem before, but I think I could explain it a bit better, so I wanted to do it again. We're given an array of distinct integers, and we want to return all possible permutations of those integers. So for the record, a permutation of a set of numbers like this would look something like this. We have 3 numbers, so we're going to have 3 positions to fill. For the first position, we have 3 choices. We can pick any of these 3 elements. So let's put a 3 over here. For the second position, we don't know which element we already picked. We could have picked this one or this one or this one for the first spot. But either way, we know we're going to have only 2 elements remaining to choose from to place over here. So there's going to be 2 different elements that go here. And after we've picked the first 2 elements, this one is already decided. So we'll put a 1 here. So 3 times 2 times.
Oh, so decision tree, maybe I'm looking at it the wrong way. Maybe it's like... Oh, it's not a branch, this is just a singular. Whoops. It only branches with how many, like, things you have left. Okay, this, I actually understand this. Okay, I think I have an idea. So, my idea that I'm thinking of, which I think I understand why he's saying, like, you iterate through the list, is so, first you'll start off with a empty array, right? And then this kind of like thing of like false, 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 right? And then so like here I'll hit this one, okay? I'm like, is this true? Have I used this before? No, it hasn't been used before, so I can use it. So then I'll take this one and I'll branch down 1 layer. So now I have this one, and it's gonna go with like true, false, false, right? And then it's gonna run through that again. We're gonna iterate through. So on the let's say we're still on the top layer. Let's say like we ignore all the recursive magic that happens here. So recursively, this is gonna return this whole tree over here. Well, let's ignore that. If we were to just say like, you know, let the recursive magic do its thing. On the top layer, it goes 1, starts a tree, then it goes to 2, it goes false. Actually, I'm just use T. Yeah, better. Starts a tree here. 3. Oops. Starts a tree here. It looks like an I. Sorry about that. So we kind of iterate through. And then our base condition is basically if you filled it up, then you're good to go. Okay. I'm gonna get copyrighted for that. I got copyright struck on my one of my previous videos because I was playing music. Obviously, my fault. I'm not mad about it or anything like that. That totally makes sense. Totally fine. But I got shadow banned because of it. So that was interesting. Now the second I posted that video, views have plummeted. I have no longer get any views, which is fine. I'm more kind of just doing this just for my self. Huh? Like basically, I'm saying if it's false, which means it hasn't been used yet, then we can use it. I'll basically then run recursion of current choice plus element. And then I'm also going to do there you go. And that runs the recursive tree. And then I'll write my edge case, my breaking case here. see if that has any sort of merit. Spell Boolean array wrong. Boolean underscore array is not defined. Did you mean Boolean array? Ah, I did spell it wrong. Okay, let's try that. So I got the wrong answer here. Well, that's interesting. Hold up. What are we doing? Oh, this wouldn't even work anyways. Would it? Because it has to go through. It's not just about going through, it's a circular motion. No, this would work. Okay, but hold up. What is this new bool thing? It's problematic because the issue is it's the same array in memory space. I'm not asking you to do the same array. That's so weird. Why would that happen? I mean, I guess Python is just Python. Sure, whatever. That's fair. Okay, we'll submit it. Oh, we're gonna have some... Yeah. Index, wait, index out of range? What do you mean index out of range? Oh! Fuck. Idiot. Idiot. What am I even doing, man? There you go. Voila. Kind of need a little bit of help on that one, but I think it made sense once I started working on it. Okay. Subset 2. Did we ever do subset 1? I don't think we did. Given an integer nums that may contain duplicates, return all possible subsets. Power set. Huh. It's just power set again? Is this not the exact same? Is this not power set? Oh, no, we did the subset. Hold on. Oh, but it's not unique this time. This time we are not unique. Sorry, I had to check my phone for a second. Okay. Do I not solve this the same way I solved the other one? Oh, what did I do? How did I solve my subsets ones? Right, so I did it, okay. Oh, shit, sorry. I'm tripping. Oh, here we go. This is how we get duplicates. Aha! I see. So what I need to do is I need to jump. So I'm gonna put a put it here. I'm gonna put a jump. If we skip it, we jump it. I'm just gonna make sure it's sorted, that's all. So I skipped this, I gotta jump. So I gotta jump that. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm missing 1. What am I missing? What am I missing? Oh, sorry. 1, 2, 3, 4, 5, 6. Okay, I got it. So this is 1. This is 2. Because of this jump, I'm now 3. Because of this jump, I am now 3. This is 2. This is 3, this is 3, this is 3, and this is 3. So that's how you skip duplicates. You gotta make the jump. So it doesn't tell me if it's sorted or not, so I'm just gonna say nums dot sort. Current array, and take index, and we're going to take previous. So when I call this, I'm going to call this current array is going to be empty, index is going to be 0, previous is going to be none. And then I'm going to put solution, this is empty array. Return solution. Oops. Put non-local solution. Okay. Then I'm gonna do if previous doesn't equal, or actually we're gonna do this. If index is equal to the length of nums, then I'm going to do solution dot append current array, and I'm going to just return. But if the previous does not equal nums of index, then we're good to do this. We're good to take. So when we're taking, I'm going to say that the recursion do current array plus, I'm going to say, oops, I'm going to say element equals nums index. So that way we don't have to call that multiple times, just store it. I feel like it's just cleaner. Okay. I'm going to do index of +1 and previous. But we're skipping. I'm going to do current array index +1 and element. I don't know if that's gonna work. Hey, it worked. Okay. Perfect. Okay, that one is done. All right, let's do word search. Given a n by n grid of characters called board and a string called word, return true if the word exists in the grid. The word can be constructed from letters sequentially adjacent cells, where the adjacent cells are horizontally or vertically neighboring. I hate these problems. There's probably like a cleaner solution, but like whenever I first started doing these, you know, when I was doing them like in C++ years ago, it was so much like breaking because it was like index out of bound, index out of bound, index out of bound. Just so much fun. Okay, so I think I have an idea of how I want to go about this. So I'm gonna start kind of drawing it out and seeing if it works. I'm gonna start with like the first thing. Actually, yeah, that's fine. We can start with the first one. I think the movement we want to do. So we want to go like this, and then we go. All right, you can kind of see the movement. So we have A, B, C, C, E, D. So what we'll do is we'll have like an index, and this index would be like right here. So like right now it's gonna be 0, so which means we're looking for A. So basically I'm gonna say like if it's A, we'll start it. So if it's A, we'll start, and then we'll also have we'll do a start, and then we'll do an ignore. So we can either take this A, which we do here, or we can ignore. So if we're taking it, we're going to basically check it with all of its neighbors. So we check here, 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 here. But we're going to do that recursively, so that way we don't have to worry about edge casing. So basically, if it exists, we're fine. But if it's not, then that breaks out. So like this here doesn't exist, this here doesn't exist, so it will never check. We will recursively go down into it, and then we'll have like a if statement there, like, hey, if you're out of bounds, then return. Like, you're not, no, we're out. But you know what? You could totally have the issue of going back and forth. Let's say I want to do D, 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 and go boom, 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 like, you know. So I think I'm gonna have to actually also have a thing of true false that represents this. Crap. Okay. I think I know kind of like where to go with this. So I'm gonna start writing. I'm thinking I might not need a global variable for this, but I'm gonna say so these two check out of bounds, so I'll write that. Check if out of bounds. Okay, so after we check out of bounds, then we can kind of start running our magic. So our choices are we check if it's valid. If it's valid, we take, or we ignore. So now I'm going to say if word of word, whoops. There's take, and then there's also ignore. Crap.
Oh, wait, but this could be so tricky.
Oh, no, okay. Ignore, we're just going to set to 0. So ignore, we're going to basically do I'm trying to remember which one's which. I always forget. Well, you know, that'll do it. No, not 2. Mod, this is chopped, like, chopped. Man, this is actually chopped as fuck. I'm gonna have to like watch this video on this because I don't like my solution at all. I hate my solution here. Wow, this is a huge decision tree that I'm running right now. Absolutely insane. Perfect. There you go. That's what I like to see. Okay. Well, I hate running these things. Like, I feel like I might get a heart attack anytime I run one of these. I don't know why. It's like, I think it's because like it's just so much of a potential error, you know. Ah, already have a little matrix. Yep. Yep. This worked. That worked too. This didn't work. Oh, because I'm Okay. What's the point of like me writing this if I'm not even gonna use it? Like, what the fuck? What? What? Really? Well, I'm confused now. Get this junk out of the way over here. I don't need this stuff. It's gonna be a lot of printing. Alright, cool. Still, give it to me. Thank goodness. I need A, B, B, C, C, E, D. No, A, B, C, C, E, D. Okay. Hey, so we had it. B, we don't have that B? Why don't we have that B? True, true, true. What? 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 Hold up. No. What are you fucking talking about? Oh my god, this pisses me off so much. How was this setting... Why is it? What is, like, actually, like, genuinely speaking, what is wrong with Python, man? It's because these are all the same fucking array, bro. It's sharing the same array in 3 different positions. Why? Why would I want that? Like, alright, bro. We're gonna... for row and length of board, for column and length of row, nope, sorry, of board 0, bool underscore matrix dot append false, bool underscore matrix dot append empty array, bool underscore matrix equals an empty array, and I'm gonna go ahead, I'm gonna print bool underscore matrix. That makes sense. Okay. So let me see. Let's just see if this creates properly. Dude. Let it rest, man. Dude, oh my goodness. Oh, I see the error. Okay. Fuck. Please, brother, please. I'm begging you. Like, will you now work? Or, dude, Python, it's amazing, but it's also, like, so annoying. And, my goodness. That's stupid. This is not going to pass. This is going to fail on, like, some weird odd case where it's going to have, like, a time running out. And if it fails... or it will pass. I hate this solution. I hate this solution. I'm curious to see.
Hey everyone, welcome back, and let's write some more neat code today. So today let's look at word search. This is a pretty good problem, and it's definitely very popular. So we're given a grid m by, we're looking for factors, therefore we is actually, so we use our word great.
Oh, hold up. Never mind. I thought someone was calling me.
Now the next character we're looking for is a C. Are there any neighboring C's? Not up, right? What about to the left? So I'm going to get the number of rows and the number of columns. So get the length of the board, we get the number of rows, and get passing in the row column, passing in 0 for the position of I, because we're all was starting at the beginning of times m, because those are the really good length of the word. So you can see this problem is not very efficient. So let's just clean this up. So
I do it differently. I'm wondering how he doesn't how he avoids that case of it just bouncing back between the two. Okay. Well, that marks 3 for today, and that's all I'm going to do today. Right? Is that all I'm going to do today? Yeah, actually, I'm done. Yeah, my brain is fried. It's 1:17. Me, I want to enjoy the rest of my Sunday. Because I got to get back to work tomorrow. Alright, well, thank you for watching, and I will see you tomorrow.